Okay, so today we're going to talk about solving log functions. You'll notice that in the notes portion that there's nothing to fill in. We've already done these properties of logarithms up here. We did them last week. And I just want to remind you about changing logs into exponentials and exponentials into logs. And these three basic log rules that say that if you have one log that is multiplied, it becomes two logs added, or one log divided equals two logs subtracted. And if you have a power, then it moves to the front, okay? And if you have two logs that have the same base, then the arguments are equal to each other, okay? So when we're solving log functions, basically you have three separate cases. You want to rewrite the log as an exponential if you have one log equal to a number. So one log equal to a number. If you have one log equal to a number, then you want to rewrite the log. If you have one log equal to one log, then the bases cancel. Cancel the logs, okay? And if you have multiple logs, condense first, okay? So in this case, for this example, we have one log equal to a number. So that's back up here. So we're going to rewrite this. We're going to use this top rule up here. So we would say the base is equal to the base. So we'd start at x. Remember, we do this circle thing to the fourth. Pick up the equals on the backside. Equals 256. Now, some of y'all are looking at this like, okay, Ms. Smith, now what do I do? So then we just go to our trusty calculator. So we go into our calculator and we go to y equals. And I'm going to clear this all out. Make sure your plots are off if you're in your calculators. And we just say, we do the left-hand side equal to y1. So x to the fourth equals 256. And then we graph it. Now we're going to have to zoom. Let's start with our basic window. You can't see the 256, so let's zoom 0 and see if we can see what our graph looks like. Come on, zoom 0 and see if it'll show us the 256. If it shows us the second line, then we can see where that line crosses. And you'll see that it crosses right here. So we do the intersection then. Second trace, number 5. Enter, enter. And we want the one on this side because logarithms can't be negative. Enter. And so the answer is x equals 4. So x equals 4. So let's make a note here. Log arguments can't be negative. Okay. So how would we have done that if we didn't have a calculator? Well, let's go over here to Desmos. Same concept in Desmos. So we would have said in Desmos, we wouldn't need to do two lines. We would have just gone to Desmos and we would have typed, come on. We would have said x to the fourth, x to the fourth equals 256. And so if we do it in one line, we would just saw where this graph is crossing the x-axis, which is right here. And so that's this spot right here. And it's not coming up by my gray dots here. So we could have done what we did in the calculator. We could have said x to the fourth. we could have put in 256. And we could have found those intersections. Let's do it the same way we would have done in our calculator here. Sorry, not y equals. There's the dot there. And so then the answer is 4. So doing the left-hand side and the right-hand side in your calculator or in Desmos is what you would do, okay? So that's how you would solve any equation, once you get it into something that you can solve it. So let's go back to our examples. So again, we have down here, we have a log equal to, well, it's not really a number, but it is a thumb. So the base is the base, so we start with the base. We'll kick up to the exponent and pick up the equals on the backside. So equals 216. So since most of you are using Desmos, let's go to Desmos. So we say 6 to the 3x. So 6 to the 3x and y equals, what was our y equals? 216. So y equals 216. So 216, so we would find where that green line, mine's green and purple, where they cross, and there's the gray dot. And it says that they cross at x equals 1. And so that would be my answer. X equals 1. So in this next example, my log base 9 and log base 9. So because my bases are the same, I would just cancel these logs. And so I would get 3 minus x equals 5x minus 15. And then I would just solve them. So I could just put this in my calculator in Desmos. So left-hand side, right-hand side. So 3 minus x. And the other side was 5x minus 15. So 5x minus 15. I need to get back into a little window here, see where these two lines cross. And they cross at x equals 3. If I was doing this in my calculator, I would do the same concept. I would do left-hand side, right-hand side. So I would do 3 minus x and 5x minus 15. And I'm going to zoom back into a good window here in 6. I would see where the graphs cross. And as long as your graph can see where they cross, which it can see it here, right here. Then second trace number 5, the intersection. 1, 2, 3. And you can see that x equals 3. Okay. So here we have 1 log equals multiple logs. Well, on this side, we need to get this into 1 log. So we're going to condense it first. So we're going to use our rules up here. And so when we condense, we always move the powers first. So we're moving from the right-hand side to the left-hand side. So we're going to use this power first. So what happens is we move the powers to the top, and we make the subtraction into division and addition into multiplication, okay? So down here, we have a power. So we're going to move it to the top. So we get log base 8 of 2 to the 5th minus log base 8 of 4. Some of you try to do all this at one time, and it's too much. So then this subtraction becomes division. So this becomes log base 8 of 2 to the 5th over 4. And so this is the right-hand side, and that's equal to this other side, log base 8 of x. Now the bases are the same. So because the bases are the same, I can cancel these. So I get 2 to the 5th over 4 equals x. Well, isn't this just a number? And if you're not sure what that number is, you can put this right in your calculator, whatever calculator you're using. So 2 to the 5th divided by, I gotta get out of that, divided by 4. Your calculator will give you an answer. See, there it is right there. So that's equal to 8. So x equals 8. That's my answer. Okay. So again, I have 2 logarithms equal another logarithm. So the plus makes multiplying. So this makes log base 5 of x times x plus 1 equals log base 5 of 6. So now I have 1 log equals 1 log. The logs cancel out. This gives me x times x plus 1 equals 6. So I go right to my Desmos. I get x times x plus 1. I get y equals 6. I see where those 2 lines cross. Well, you'll notice that they cross 2 times. They cross here, which is -3, and they cross here at 2. Well, if I go back over here to my answers, I get x equals -3 or x equals 2. But what did we say up here? We said that log arguments can't be negative, right? We said log arguments can't be negative. Well, if I plug -3 in right here, I get log 5 of -3. So -3 can't be my answer. So 2 is my only answer. Okay? So that's my only answer now. So now I have multiple logs equals a number. So now what do I do with that? Well, anytime I have multiple logs, I'm going to condense that. So addition means multiplication. So this makes log base 2 of x8. Well, do we usually write x8? No, we write 8x equals 4. Well, now we have 1 log equals a number. Well, we go back to the rule from before and we rewrite it. So we say 2 to the 4th equals 8x. Well, 2 to the 4th is 2, 4, 8, 16. And we divide by 8, so x equals 2. Okay, so same thing here. The ln of x divided by 3 equals 2. Well, how would we rewrite this? What is ln? What base is ln? Well, remember that ln of x is the same thing as log base e of x. So this is base e, right? So this is like saying this has base e in it. So when I rewrite this, I would say e squared equals x over 3. And so that's what I would put in my calculator. I would put e squared equals x over 3. So I don't have an e as a number, but my calculator recognizes e as a number. When I put it in, it automatically puts in a number. So when e squared equals x divided by 3. Well, it just drew the one line because I didn't tell it that I want this other line. In order to make it a line, remember I got to put y equals. So now it's got the 2 lines, and I just need to see where these cross. So they cross at this point. Well, I know y is 7.38, so x is 22.167, and that's my answer. And that's all you have to do, okay? So just follow those 3 rules.